vocabulary here. We want to be able to talk about what are called coterminal angles. And the way that I think of this is I go on the root word, which is terminal. Terminal means where something ends. So coterminal means angles that co means together, end together at the same spot. So a perfect example of a coterminal angle is this first angle here is a 30-degree angle. However, I can come up with a very similar angle by, instead of stopping at 30, going around in a big loop. And what does that mean I've actually done? Well, I did the 30 degrees, but then I went in a full circle after that, which is adding another 360 for a total of 390 degrees. These two angles are different, but they end at the same spot no matter what. So that means that they are coterminal angles because they end, terminal, together at the same spot. Okay, there are other coterminal angles too. Here's another one. We've got a 30-degree angle again, going counterclockwise, but you could end at the same spot if you went clockwise. So instead of going 300 or 30 in one direction, we can go to make the rest of the circle in the other, which is a 330. We're going clockwise, which means the angle should be negative, so negative 330 degrees. But notice they are coterminal because together they end at the same spot. They still end at the same angle. It's just looking at it from a different perspective. So what do we know about coterminal angles? Well, coterminal angles vary by which way you're going around the circle and how many times you go around the circle. So coterminal angle means if I want to go around the circle an extra time and come back to where I started from, I can, and I'll land at the same spot. And that's what this formula down here towards the bottom says. If I want to find a coterminal angle, I can add a 360 once, twice, 3 times, 4 times, it doesn't matter. Or I can actually take away a 360 and go in reverse, which is what we did with this angle up here, is I can actually take away a 360 once, twice, 3 times, and go in reverse and make a similar angle just going around the circle clockwise instead of counterclockwise. And you'll still get an angle that stops at the same point. It's pretty cool. So coterminal means angles that together, terminal, stop at the same value on your picture. So they won't have the same numerical value, but they'll have the same actual picture for your angle. It'll land in the same spot. So in this next little group, they want us to kind of talk about our angle that they're giving us and then find some angles that are coterminal with it. So our first angle, 86 degrees. Well, we know that 0 degrees, our starting point, is here on the x-axis, and we know that 90 degrees is up here. So our actual angle, our 86-degree angle, is a little bit shy of the 90 degrees. So just shy. 86, and it's positive, so we're going in counterclockwise motion. Would look something like this. Now, what they want us to do, though, is come up with a least positive measure that is coterminal with the given angle. And the key here is that a lot of people miss this, is they want a positive angle. Okay, well, the only way to get a positive angle is to continue going counterclockwise. So the only way to get something that's going to end at the same spot but still positive, because that's what coterminal means, end at the same spot but still be positive, is to basically go to my 86 and then keep on going around my circle and come back. Well, what does that mean I did? I took my 86 degrees I had, and then I went around in a circle and came back and added another 360. So really that angle is 86 plus 360, which is 446. That is the least positive, because it's a positive angle, that is also coterminal. Now, I could go around the circle again, but that wouldn't be the least or smallest value possible that I could get. Let's try another one. Let's take a look at B. In B, we've got 58 degrees and 40 minutes. So we're going to start here on the x-axis like you always should. The angle is positive, so we're going to go in counterclockwise motion to 58 degrees, which is kind of partway through to 90, but not quite there. So we'll say that this is 58 degrees and 40 minutes. So the same idea, they want the least positive angle that is coterminal, which means I'm going to go my 58, then I'm going to keep on going around and come back to my angle. And how you do that is you have to go your 58 degrees and 40 minutes, and then go around the circle and come back. So adding another 360 degrees to go around a circle. Well, notice that there should be a hidden 0 here for our minutes. If you've got 360 degrees, it means there are no minutes, and I can add normally. So I'll get my 40 plus my 0 minutes is 40 minutes, and then my 360 plus my 58 is 418 degrees and 40 minutes, and that's my least positive coterminal angle. Let's take a look at C. In C, we've got a little bit different. We always start again on the x-axis on the right here. What we should be noticing with this one that is slightly different, and it does make a huge difference, is that this angle is negative, which means we're going to be going clockwise, not counterclockwise. Also, 90 degrees is making a right angle from where you start. So negative 90 degrees would be going to clockwise direction by 90 degrees. So if I'm looking at negative 98, it means I'm going to go a little bit past that to negative 98 degrees. Should be somewhere over here in quadrant 3. Because remember, no matter what, even if we're going clockwise, when you count quadrants, you still count counterclockwise when you're counting the quadrants, no matter what, if they ask you what quadrant it's in. So they want the least positive coterminal angle. So there's actually a quick way to do this, which is starting at the position. If they want a positive angle, that means going counterclockwise and landing again at the same spot. I don't need to go around in a circle. I just need to go and kind of match up and end at the same spot. So how do I figure out what that angle is? Well, notice that these two angles together actually make up a circle. So if I take a circle 360 degrees and take away the angle I've already used, which is the 98 degrees, together it should be the full circle, which would give us, let's see, 262 degrees as my, again, it should be a positive angle because it's going counterclockwise. So that's going to be my least positive angle. Yes, technically I could go around the circle and come back to this and get another value, but it wouldn't be the smallest. This is the smallest positive value that's coterminal with the angle that I had. Okay. Let's take a look at a couple more. Let's take a look at problem D. In problem